Clinical brain profiling relates to a hypothesis of what are the underlying causes of mental disorders. Clinical brain profiling presumes that all mental disorders can be described using three types of global brain perturbations. The first one is neural complexity, the second one is matching complexity, and the third one is the perturbation to the construct of internal configurations or internal representations. Matching complexity talks about a balance between connectivity dynamics, mainly overconnectivity or disconnectivity dynamics. Matching complexity relates to the extent that constructs or events in the environment match or not mismatch internal configurations. And internal configurations relate to the Hebbian algorithm of experience-dependent plasticity, which creates an internal model in the brain of outside environmental occurrences, including psychosocial occurrences. Neural complexity is divided, as exemplified before, into disconnection dynamics and overconnection dynamics. Clinically, these types of perturbations relate to psychosis and to deficiency syndromes, like in functional psychosis in schizophrenia. The assumption is that disconnection dynamics fragments the global organization in the brain, allowing different brain systems to act statistically independent. Overconnectivity creates freeze or constriction of brain dynamics, allowing the symptoms of restricted thought process and so on that we find in negative symptom schizophrenia. Matching complexity is the dynamics between the extent that internal configurations and external events match, and can be divided into two types, optimization dynamics and de-optimization dynamics. De-optimizations means that there is an increased distance between what happens and the internal configuration. It is like Hamming distance, increase of Hamming distance dynamics. And the assumption is that the emergent property of de-optimization dynamics relates to depressed mood, while emergent property of optimization dynamics relates to elevated mood and also mania. The internal configurations determine the way that we experience the environment and react to it. Thus creates a whole construct of attitudes which can be clinically described as a personality or personality traits. So we can see that these three types of brain perturbations, the one that relates to matching complexity, neural complexity, and internal configurations, span the wide range of mental disorders that we find, from personality disorders to schizophrenia, negative positive symptom-like, and mood changes. These three types of perturbations are governed or related to three main, let's say, neural systems that have a regulatory or integrative effect in the brain. Neural complexity has been found to be related through the dynamics of what we see in schizophrenia patients to the dopaminergic system and to the frontal lobe. That's some kind of a huge circuit that relates to substantia nigra, to the ascending dopaminergic system, and to the feedback that comes back to the nigra and striatum from the cortex, are probably some kind of regulators of connectivity dynamics, allowing a good neural complexity level, meaning a good balance between disconnectivity and overconnectivity. Matching complexity, which relates to the extent that internal configurations are related to the incoming experience from the environment, relates to systems that have ability to combine information from internal representation and external environment. That will be the thalamic systems and related thalamic circuits, cortical thalamic and thalamic cortical circuits. Relating to internal configurations or to the establishment of sets of massive connectivity constructs, Hebbian-like constructs, is probably correlated with a hippocampal system and hippocampal circuits coming from the cortex and ascending back to the cortex. So what we can find now, we can see that clinical brain profiling has a general framework of dynamics related to these three aspects, and these three aspects are also related to some kind of brain anatomical constructs and functions.